Hello everyone, this is a continuation of discussion on statistical measures, and we want to talk about measures of spread of data or dispersion. There's four measures out there: range, interquartile range, standard deviation, and variance. Range, we talked about it before, is the difference between the greatest and the least data values. So I have a data value here, and I took the liberty of sorting them. So it's sorted from the least to the greatest: 7, 8, 14, 18, 22, 26, 40, and 43. And you see that the least value is at the top 7. The greatest value is 43 at the bottom. So obviously, you're going to go 43, take away 7, which would be actually 36. So we're going to say 43 minus 7 is 36, and that is the range of the data set. So very clear, the easiest measure of spread of data. Interquartile range is the range of the central half of a sorted data set. So you have a data set. If it is not sorted, you must sort it first, and then you find the range of the central half of this data set. So what does that mean? You see that we have 8 data values here. If I cut it in half, there's going to be 4 upper values and 4 lower values, okay? Now, if I consider the upper half, I have 4 numbers there. So I have to find the median of those 4 numbers. If I had 5 numbers, then I would say the middle value would be the median. But right now, unfortunately, I have 4 of them. So that means the 2 middle values I have to pick, and as we discussed extensively in the past, find the mean or the average of those 2 middle values. And that is going to be called the first quartile. That's what we call it. So I'm going to find Q sub 1, which is the first quartile, and that's going to be 8 plus 14 divided by 2, and that would be, I would say 22 divided by 2 is 11, I guess, right? So the first quartile is 11, all right? That's what we find. Now the bottom part, again, same scenario. We're going to find the third quartile, we call it, 26 plus 40. That is 66 divided by 2 is 33. So the third quartile is called, it is 33. Q sub 3 shows the third quartile, okay, quartile. And Q sub 1 stands for first quartile, okay, quartile. So we found Q1, we found Q3, first quartile, and third quartile. What are we trying to calculate? The interquartile range. What is interquartile range? The range of the central half of a sorted data set. So basically, we said that the range is the difference between the greatest and least values. So we're going to find the difference between Q1 and Q3 by a simple subtraction, of course. So we're going to say interquartile range is Q sub 3 minus Q sub 1 divided, and not divided by nothing, it's just the difference, Q3 minus Q1. Third quartile minus the first quartile. In this case, we have 33, take away 11, which would be 22. So if they say calculate interquartile range, the answer would be 22. Okay? What is interquartile range again? It's the range of the central half of a sorted data set. This was the central half. Like, look, half of the upper part is 11, not half. The median of the upper half is 11. The median of the bottom half is 33. So when you find the range by subtracting them, that is called interquartile range. It's not a bad idea to mention that the median here, in this case, which would be actually the mean or the average of 18 and 22, is also known as the second quartile. So 18 plus 22, if you add them up divided by 2, that's going to be 40 divided by 2, that's 20, okay? So this 20, I know you're going to say this is the median of the data set, and you are right, actually, it is the median, but it is also called the second quartile. So we have first quartile, second quartile, third quartile. Okay, first quartile is the median of the upper half of the data set when you sort it. Third quartile is the median of the bottom part, bottom half of your sorted data. And the Q sub 2, the second quartile, is the same old median that we had before. It's just another name for that, okay? So that's how you calculate the range. That's how you calculate interquartile range. And I hope you understood how we calculate these. The other two measures of spread of data, standard deviation and variance, we have to talk about them extensively in a separate lecture. But briefly, variance is a measure of spread of data, and it's calculated by this formula. So x1 minus x bar, that means that you grab the data values, each one of them, and subtract the mean from it. And you know how to find the mean. And these differences, x1 minus x bar, x2 minus x bar, all of these are called deviations. And sometimes x1 is larger than the mean, so we end up with a positive answer. Sometimes we end up with a negative answer if the mean is larger than x1. Imagine x1 is like 7 and the mean is like 10. So 7 minus 10 will be negative 3 in that case. Now, in order to avoid negative numbers, mathematicians are squaring these deviations, okay? So x1 minus x bar, x2 minus x bar, these are called deviations. And when you square them, you always end up with a positive answer. And when you add all these deviations, squares of the deviations, I should say, squares of the deviations, and you divide it by n, basically you're finding the average of the square of the deviations, then that is called variance. The number that you get is called variance. I'll show you a separate example on that. And if you take the square root of that number you end up with, let's say the variance was 16, you take the square root of 16, that is called standard deviation, which is a measure of the amount of dispersion as a representative of the data. If you look at these two examples here we have a bar graph, and in the middle we have the mean. It shows data clustered about the mean. All right, if you look at the data, it shows that data is clustered about the mean. But in this one, in this other data set, data are dispersed, of course. Okay, so there's a difference between these two. And a measure of the amount of dispersion as a representative of the data is what we call it standard deviation. And as I said, as soon as you calculate the variance, whatever number you got, you simply take the square root of the variance. That will be the standard deviation. And I'm going to show you a separate example on how we calculate the variance in an organized manner. Okay, and variance, standard deviation, I'm going to show you separate examples, but this lecture focused on interquartile range and how we calculate it. We said it's nothing but Q3 minus Q1, or the difference between the first and third quartiles. Okay, I hope you're going to practice, and in the next lecture I will extensively talk about the variance and standard deviation. And I believe we are almost, towards the end of statistics unit. Thank you very much for your attention.